Assalamualaikum to Dr. Kazrana. My name is Ahmad Shafiq bin Rahmat from Group 17. So this is our answer for question 2 tutorial. A is the operation of squirrel cage induction motor will change when the voltage supply frequency is decreased. Predict 5 changes and briefly justify each of the changes. Okay, so the first answer is synchronous speed decreases, which from the formula and sync equal to 120 F divided to P. When the frequency F decreases, the synchronous speed also decreases. This causes the rotor to run at a lower speed. The second one is rotor speed decreases. The rotor speed is always less than synchronous speed. When the synchronous speed decreases, rotor speed also decreases while slip slightly adjusts to maintain torque. Next is magnetic flux increases. If the flux is proportional to V divided to F, if voltage stays constant and frequency decrease, the magnetic flux will increase, which the high flux may cause core saturation. And the next one is increased core losses, which the higher flux increase the core losses due to increased magnetic saturation. This can cause more heat in the stator core. And the last for question A is torque production changes. Okay, if the voltage is constant while frequency decrease, the torque characteristic will be changed, and the motor may produce excessive starting torque but poor running efficiency. Okay, next is question B. Okay, for question B, a three-phase well-connected 35 horsepower 400 volt 50 Hz 4 poles. One induction motor has a stator resistance and a stator refer motor resistance of 0.26 ohm and 0.24 ohm respectively. The rotational losses are 450 watt and the core losses are 550 watt. Okay, for the first question in B is calculate the motor current and the speed of the motor. Okay, based on the value given, we can change the value of 35 horsepower to kilowatt, which we need to times with 746. Okay, 35 horsepower times with 746, we got around 26.11 kilowatt. Okay, from the answer of P out, we need to add the value for rotational losses, which is 26.11 kilowatt plus with 450 watt. So we got here is 26.56 kilowatt. Okay, next is at normal condition, the value of slip is between 2% until 7%. So just assume for slip is 0.042, which 42% slip. And next we calculate the air gap power with equation air gap equal to PD divided by 1 minus S. The PD is from the P out plus with P rotational. Okay, so 26.56 kilowatt divided by 1 minus 0.042, where we get the answer is 27.72 kilowatt. And the second calculation is rotor copper losses, which the formulas we use is PCU equal to S times with PG, where the S value is slip that we assume 0.042 and the PG is for air gap power that we got before 27.72 kilowatt. And for this rotor copper losses, we got around 1.164 kilowatt. Okay, after calculate all of the power and losses, we need to calculate the value of I with using the formula PCU equal to 3I square equal to resistance, which the copper losses 1.164 kilo equal to 3I square times with 0.24, where the value of I we need to find. So we just change the value to right and left. Okay, for 0. Okay, the last answer is 1.164k equal to what 0.72 I square. Okay, so here we want to get the value of I2, so we need to replace the 0.72, where the last step is 1.164k divided by 0.72. The square we need to change to right side. and we got square root of 16161.67, where we got for current around 40.2 A. So it's same with the answer, which is 40 A, and the speed of rotor is 1 minus s, and sync, and sync is we got from the formula is 120 times with frequency divided by pole, which the frequency for this question is 50 and the pole is 4. So we got NSYNC around 1500 rpm. So the formula for torque speed is 1 minus 0.042 times 1500. So we got around 1437 rpm. Okay. Okay, for the last question is to calculate the resistance that added to the rotor circuit that reduced the motor speed by 8%. Okay, so the last question is the speed is reduced by 8% from the value of all RPM is 1437.6 RPM. So we just do times with uh, 1 minus 0.08, where we get the answer is around the new rotor speed is around 1322.6 rpm. Okay, next step is we calculate the slip for old slip and new slip. For old slip is we use the value 1437.6 rpm, and the new slip is the latest one when the speed of rotor is reduced by 8%. Okay, from that percent we use the value is 1322.6, where the old slip is answer for old slip is 0.0416 and the new slip is 0.1183. Okay, after that we need to calculate for resistance, where 0.24 divided by the old slip 0.0416, and we got the answer is around 5.764. And after that we calculate the new rotor resistance, the R total 0.1183 from the new slip, we times with the latest resistance, which is 5.769. Okay, from this R total we got around 0.682. Okay, after calculate the R total, we need to get the value for add resistance value, which is the R total minus with 0.24. Okay, after that, okay, we calculate for winding losses before add resistance, which the rotor with the formula of 3 times to 40 square times with 0.24. For rotor, we got around 1152 watt, and stator also the same formula, which but with this different resistance we use is 0.26, and we got the answer around 1248 watt. And after calculate both of the rotor and stator, we need to total the value. So 1152 plus 1248 watt. So we got for before adding the resistance, we got around 2400 watt. Okay, for winding after add resistance. Okay, so we need to use the value for resistance is uh, the R total, which is 0.682, with the same formula 3 times 40 square times the new R total, which is 0.682. So we got around 3273.6 watt. Okay, from the total, this is for the rotor. The stator is the same with the before add the resistance. So we just plus the value 1248 watt plus 3273.6 watt is equal to 4500 to 3.2 watt. So the answer is around quite similar with the doctor given for question B2.